Hello everyone, welcome. In this video, let us solve this exponential equation. So we have g to the power of g is equal to g to the power of 2. Now, from inspection and by observation, we have it that g is equal to 2, right? But then we are correct. But this is just one of the values of g. Let's then solve for the other values of g. So we have g to the power of g is equal to g to the power of 2. First, let's divide both sides by g to the power of 2. So over g to the power of 2. This divide this, you have g to the power of g over g to the power of 2 is equal to 1. Okay. Now at this junction, let's have it that if you have a to the power of n over a to the power of m is equals a to the power of n minus m. In this sense, if you have the same base joined by division sign, you simply pick one of the base and subtract the powers. So applying this right here, you have the same base, so pick one of the base, right, and then subtract the power. So g minus 2, okay, is then equal to 1. Now at this junction, right, I'm then going to introduce what is called the natural logarithm. So on both sides, ln g to the power of g minus 2, okay, is equal to ln 1, okay. So with this, I'm then going to introduce one of the properties of logarithm, that if you have log a to the power of b, okay, this equals power b then becomes b, then you have logarithm of a. So applying this rule right here, you have it that power g minus 2 becomes g minus 2, then you have ln g times ln g is equal to ln 1. Okay, good. So with this, you have it that g minus 2 times ln g is equal to ln 1 is equal to 0. At this junction, g minus 2 can be equal to 0 and ln g can be equal to 0. So for the first one, g minus 2 is equal to 0. So g minus 2 is equal to 0, or ln g is equal to 0. Now from here, we have a linear equation. So g is equal to 2, right? Now, we've gotten the value of g initially to be 2. Okay, let's then get the other values of g from this equation, that ln g is equal to 0. Now, to then solve for g right here, the first thing to do is to eliminate this ln. Now, to eliminate this ln, I will bring in e on both sides of the equation. So e to the power of ln g is equal to e to the power of 0. Okay, so e will cancel ln. What you have is g. So g is equal to e to the power of 0. And any number to the power of 0 is equal to 1. So g is equal to 1. Okay, even though you have a to the power of 0 is equal to 1, s to the power of 0 is equal to 1, any number, anything to the power of 0 is equal to 1. Now at this junction, you have it that g is equal to 1. Okay, so we've gotten the other value of g, right, apart from g equals to 2. Now let us now check whether the values of g that we've gotten, right, fit into this equation. So check. We have the equation to be g to the power of g is equal to g to the power of 2, right? Now, for the first value of g, which is 2, so we have 2 to the power of 2, right? Will equal, okay, g as 2 to the power of 2. So let's now check for it. We have 2 to the power of 2 as 4, which equals 2 to the power of 2 as 4. So as you can see, 4 equals 4. So that means that this g to the power of 2 suits the equation g to the power of g equals g to the power of 2. Okay, let's then test for the other values of g, which is g equals to 1. So we have the equation to be g to the power of g is equal to g to the power of 2. So when g is equal to 1, so g as 1, then g as power 1 is equal to g as 1 to the power of 2. So we 1 to the power of 1 equals 1 to the power of 2. Let's now confirm it. 1 to the power of 1 is equal to 1 to the power of 2 is 1 times 1, 1 in two places, which equals 1. So they can see 1 is equal to 1. So therefore, the value of g equals to 1 suits the equation g to the power of g is equal to g to the power of 2. I hope you enjoyed the video. Please don't forget to like the video, share the video to your friend, and also please don't forget to subscribe. Subscribe now. Thank you very much. See you in the next video.